Hi guys, welcome to my channel, Pilots of the Caribbean. Today we are going to review the air conditioning system for the Boeing 737. Please put a like on my channel and subscribe. Thank you and enjoy the video.
Conditioned air for the cabin is provided by either the airplane's air conditioning packs or from a preconditioned ground air source. This conditioned air is used to control temperature for the flight deck, cabin, cargo compartments, and equipment cooling. Pack control, zone temperature control, cabin air recirculation, fault detection, and overheat protection are all automatic. A portion of the air conditioning system controls temperature by using two identical packs to process bleed air from the engines, APU, or a ground air source. Bleed air enters the system from the left and right engines through pack valves. The conditioned air from the left pack then flows to the flight deck where it is used for heating and cooling. The flight deck requires minimal air. Remaining air from the left pack is drawn into the mix manifold where it is combined with air from the right pack and two recirculation fans. This mixed air is then distributed through the left and right sidewall risers to an overhead distribution duct in the passenger cabin. To further enhance cabin temperature control, the aircraft is divided into three zones. A trim air system fine-tunes the air temperature within the respective zone. If the engines, APU, or ground high-pressure air are unavailable to provide bleed air to the packs, the system can also use preconditioned air from a ground air source. The air conditioning system is monitored and controlled using the air conditioning and bleed air panels located on the first officer's side of the overhead panel. The panels consist of the following indicators, switches, and annunciators: an air temperature indicator and selector switch, the trim air switch, zone temperature lights, temperature selectors for the three zones, a dual bleed light, ram door full open lights, recirculation fan switches, pack switches, and the pack lights. The packs are controlled by two identical pack controllers, each providing primary and secondary control of the various functions. Air can be supplied to the packs from the engines, APU, or a high-pressure ground air source. Normally, the left pack uses bleed air from engine number 1, and the right pack uses bleed air from engine number 2. If bleed air from the engines is unavailable, the APU is capable of supplying bleed air for two packs on the ground or one pack in flight. A single pack is capable of maintaining pressurization and acceptable temperatures throughout the airplane up to the maximum certified ceiling. Before bleed air enters the pack, it passes through a flow control shutoff valve, also known as the pack valve. This valve is operated by each respective pack switch. Once the bleed air enters the pack, it is cooled by a primary heat exchanger using ram air. The cooled air then enters the air cycle machine, where it is compressed and cooled even further through a secondary heat exchanger. After leaving the air cycle machine, the air is sent through a water separator before mixing with bleed air to obtain a specific temperature. Finally, cooled air leaves the pack and flows to the mix manifold. The air conditioning packs are controlled from the flight deck using the pack switches. Switch positions are off, auto, and high. The pack valve regulates the airflow based on the aircraft altitude and switch position. When the respective switch is in the off position, the pack valve is closed and no air is flowing through the air conditioning pack. When the pack switch is selected to high, the packs regulate to high flow. With both packs operating and both switches in auto, each pack operates at low flow. However, if only one pack is operating, the system automatically switches to high flow in order to maintain adequate ventilation. Automatic switching to high flow is inhibited when the airplane is on the ground or in flight with the flaps extended to ensure adequate engine power for single-engine operation. Automatic switching to high flow also occurs if both engine bleed air switches are off and the APU bleed air switch is on, regardless of flap position, air-ground status, or number of packs operating. With engine bleed air switches in the on position, do not operate the air conditioning packs in high for takeoff, approach, or landing. The temperature of the aircraft cabin, the supply duct, and the air conditioning packs can be monitored with the air temperature source selector, located at the top of the air conditioning panel. Since only one temperature can be displayed at a time, the source selector can be switched between the various readouts. The supply duct temperature displays the temperature of air entering the cabin within the selected zone. The forward or aft passenger cabin position displays the cabin temperature within the selected zone. Select left pack with the air temperature selector. This position displays the temperature of air just downstream of the selected air conditioning pack. When the pack switches are positioned to auto or high, the pack valves are signaled to open. The pack valves function as both flow control and shutoff valves. They are electrically actuated and pneumatically operated. These valves let a controlled amount of air flow from the pneumatic system into the air conditioning pack. The pack light illuminates to indicate a pack trip-off due to an overheat or failure of both primary and standby pack controls. When the pack detects an overheat condition, the related pack valve closes and the pack light, master caution, and air conditioning annunciators illuminate. If the fault condition is corrected, pushing the trip reset switch resets the pack light in an overheat condition. The related pack valve reopens and the light extinguishes. If the fault condition is not corrected and the pack light remains illuminated after pushing the trip reset, then the fault is due to a dual controller failure. In a dual controller failure scenario, the pack operates uncontrolled with the pack valve open, and it does not close until the pack is commanded off with the pack switch. During master caution recall, the light illuminates to indicate failure of either primary or standby pack control. The light extinguishes when the master caution is reset. The ram air system provides cool ram air for the heat exchangers. The ram air doors are controlled automatically by the pack controllers. On the ground or during slow flight with the flaps extended, the ram air inlet doors move to the full open position. This provides maximum cooling for the air conditioning packs. When the ram air doors are full open, the blue ram door full open lights illuminate. During normal cruise flight, the ram air doors modulate between open and closed. This movement is automatic. There are no cockpit controls or position indicators other than the ram door full open lights. To prevent slush and debris ingestion prior to liftoff and after touchdown, deflector doors are installed forward of the ram air inlet. The deflector doors extend automatically while on the ground only and are controlled by the air-ground safety sensor. The main distribution manifold consists of a mix manifold, ducting, and a ground air service connector. The mix manifold receives air directly from both air conditioning packs or an external preconditioned air source. The air is then mixed with recirculated cabin air supplied by the recirculation fans. The mixed air then flows through ducting into the aircraft cabin. Air supplied to the flight deck is not recirculated air from the mix manifold. It comes directly from the left air conditioning pack. Recirculation fans help maintain overall cabin air circulation while reducing air conditioning system pack load and engine bleed air demand. Air from the cabin and electrical equipment compartment is drawn to the area around the forward cargo compartment where it is filtered and then recirculated to the mix manifold. HEPA filters are installed to improve the quality of recirculated air. The auto position is the normal operating position for the recirculation fan switch. In flight, if either or both packs are selected to high, the system assumes that the flight crew wants additional bleed air to be routed through the air conditioning pack. This eliminates the need for the recirculation fans to operate. When one pack switch is in high, the left recirculation fan shuts down. When both pack switches are in high, both recirculation fans shut down. In this example, we will observe how recirculation fan logic operates while the aircraft is on the ground. Select the left pack switch to high. Notice that both recirculation fans are still operating. Since bleed air is not as critical on the ground, the fans continue to operate. When both pack switches are set to high, the left recirculation fan shuts down. The right recirculation fan continues to operate regardless of pack switch position. The 737-800 is divided into three compartments for temperature control: the flight deck, the forward section of the passenger cabin, and the aft section of the passenger cabin. The ambient air temperature for the forward and aft zones can be displayed on the air conditioning panel. Select the aft passenger cabin with the air temperature source selector. The aft cabin temperature is 80 degrees Fahrenheit. The zone temperature lights illuminate to indicate specific overheat or failure of the associated zone controller. The control cabin zone temperature light indicates a duct temperature overheat or failure of the flight deck primary and standby temperature control. A forward or aft cabin zone temperature light indicates duct temperature overheat. During master caution light recall, the control cabin zone temperature light indicates failure of the flight deck primary or standby temperature control, and either the forward cabin or aft cabin zone temperature light indicates failure of the associated zone temperature control. The temperature of the aircraft cabin is controlled by the air conditioning packs and trim air system. The desired zone temperature is adjusted by individual temperature controls. The selector range is approximately 65 to 85 degrees Fahrenheit. Let's take a look at temperature control during normal operations. Selecting the trim air switch on opens the trim air pressure regulating and shutoff valve, allowing operation of the individual trim air modulating valves. With the trim air selected on, both packs produce an air temperature to satisfy the zone which requires the most cooling. Zone temperature is then controlled by adding the proper amount of hot trim air to the supply ducts. Hot trim air is routed directly from the aircraft pneumatic manifold prior to entering the air conditioning packs. The amount of trim air added is controlled by the individual trim air modulating valves. These valves are controlled with their own controllers, which receive a signal from the temperature selector switches. Rotating the control toward cool or warm manually sets the desired temperature via trim air modulating valve controllers. The trim air valves modulate automatically in relation to the position of the temperature selector. In this configuration, both packs are producing 65-degree air to satisfy the zone that requires the most cooling. The trim air system then adds hot air into the forward supply duct to produce a temperature of 75 degrees Fahrenheit. More hot air is added into the aft supply duct to produce a temperature of 85 degrees Fahrenheit. This produces cabin temperatures to satisfy all the different zones. In this example, we will discuss how trim air is affected during single pack operations. Select the left pack switch to off. During single pack operation and the trim air selected on, zone temperature is controlled the same as during two-pack operation. During single pack operation with the trim air selected off, the pack attempts to produce an air temperature to satisfy the average temperature demands of all three zones. Let's go back to two-pack operation now. If both packs are operating and the trim air switch is selected off, the system operates in the split pack mode, causing both packs to operate independently. The left pack will produce an air temperature to satisfy the flight deck. The right pack will produce an air temperature to satisfy the average of the forward and aft zones. Select the trim air switch to on. And rotate the forward zone temperature control to off. If any zone temperature control is selected off, the temperature selector is ignored by the temperature control system, and the associated trim air modulating valve closes. With all three temperature controls set to off, the aircraft is in fixed cabin temperature mode. The left pack produces 75-degree air, and the right pack produces 65-degree air. If there is any failure affecting the supply of trim air, the temperature control system commands both packs to operate independently. If flight deck trim air is lost, the left pack produces air at the temperature selected on the control cabin selector. The right pack satisfies the zone which requires the most cooling between the forward and aft zones. If the failure affects the supply of trim air to the cabin, both packs will again operate independently. The left pack satisfies the temperature required by the flight deck. The right pack satisfies an average temperature of the forward and aft zones. The conditioned air is distributed to the flight deck and passenger cabin. The flight deck air is routed into several risers which distribute the air to the floor, ceiling, and foot-level outlets. The air diffusers located on the floor deliver airflow as long as the manifold is pressurized. There is a dual-purpose valve behind the rudder pedals of each pilot. This valve provides warm air for the pilot's feet and for defogging the inside of the windshields. Each valve is controlled by knobs located on the captain's and first officer's forward panel. In the passenger cabin, sidewall risers go up the sidewalls to supply air to the overhead distribution duct. The overhead distribution duct routes air to the overhead ducts and sidewall diffusers. Gasper air is conditioned air provided for individual passenger comfort and is adjustable by each passenger on their overhead panel. Gasper air is distributed through overhead Gasper air ducts to each passenger service unit and is available anytime there is airflow for air conditioning. The air conditioning system is also used to cool the electronic components in the cockpit and the E&E compartment. The equipment cooling system consists of a supply and an exhaust duct. Each duct has two fans, normal and alternate. The fans in the supply duct push cool air over the display units, FMC displays, the center aisle stand, and the equipment racks in the E&E compartment. The fans in the exhaust duct draw warm air from the display units, FMC display units, circuit breaker panels, electronic panels, and the E&E compartment. When the airplane is on the ground, or during low pressure differential, the overboard exhaust valve opens to allow warm exhaust air to be expelled. During flight, the overboard exhaust valve closes, and the exhaust air is ducted around the forward cargo compartment. Flow detect sensors monitor the movement of air through the system. When there is not sufficient cooling airflow, the off light, master caution, and overhead light illuminate. The off light illuminates for either the supply or exhaust fan, indicating which fan has failed. Selecting the alternate fan should restore airflow and extinguish the off light within 5 seconds once airflow is detected. If an over-temperature occurs on the ground, alerting is provided by a crew call horn in the nose wheel well. The overboard exhaust valve is in the aft center portion of the E&E compartment. The overboard exhaust valve has two functions: controlling the quantity of equipment cooling exhaust air and assisting with smoke removal. On the ground, the overboard exhaust valve is full open. When the airplane starts to pressurize, airflow through the valve increases and the valve closes when a certain threshold of airflow is reached. When either pack switch is selected to high and the right recirculation fan switch is selected off, the valve is driven open. This increases ventilation in the smoke removal configuration. The cargo areas are heated through warm air directed around the cargo compartments. The forward cargo compartment is warmed by recirculated air from the passenger compartment. When the overboard exhaust valve is closed, air from the E&E compartment is also ducted around the forward cargo compartment. The aft cargo compartment is warmed by recirculated air from the passenger compartment. The air is then ducted overboard through the outflow valve.